Hi everybody, here is a question that was recently given on an exam and a lot of students found it kind of tough. The question says, to determine the height of a flagpole, Abby throws a ball straight up and times it. She sees that the ball goes by the top of the pole after 0.5 seconds and then reaches the top of the pole again after a total elapsed time of 4.1 seconds. How high is the pole above the point where the ball was launched? Now from the question, it's very clear that this ball is thrown vertically up. So this is one-dimensional motion. And then the ball passes the top of the pole once after 0.5 seconds, and the ball keeps going up and above, reaches a maximum height, and then on the way down again reaches the top of the pole after a time of 4.1 seconds. And you have to find the height of the pole. Now do remember that in all of the equations in kinematics, you need to know the initial velocity of the object. And in this particular problem, the initial velocity of the object is not given. So the idea must be to first find the initial velocity v0. So this is the flagpole, and it reaches the top of the pole on its way up after 0.5 seconds, and then it keeps going up, reaches somewhere, and then comes way down, and on the return journey it passes the top at 4.1 seconds. Which means that to go from the top of the pole down back to the ground, it would take another 0.5 seconds. And I'm sorry for that confusion. So that means the total time that the object takes is 4.6 seconds. So the total time taken is 4.6 seconds to start from the ground and come back to the ground. And therefore the time taken for it to reach the top of its journey, not the top of the pole, but top of the path, that time is going to be half of this, which will be 2.3 seconds, right? I'm just saying that. So we will, no, let's use the time, the total time taken, 4.6 seconds. Now because when you take the total time as 4.6 seconds, you know that the displacement is 0. Because the object starts from the point and returns back to the same point, the displacement is 0. So delta y is 0. And we do not know, that's what we're trying to find. T is 4.6, so T is 4.6. And then you're going to go plus half times negative 9.8. Half times negative 9.8 becomes 4.9. So you have negative 4.9 times 4.6 squared. So when you put the numbers and calculate, you're going to get the velocity as 22.5 meter per second. And once you get the initial velocity, now we can find the height of the flagpole, because we know that it takes 0.5 seconds to reach the top of the flagpole. Correct? So we have the initial. Okay, so now we know the initial velocity, and we're trying to find the height of the flagpole, and the time taken to reach the top of the flagpole is 0.5 seconds. So that will be the time. A is negative 9.8. And then use the same equation again. Plug it back into the equation. Calculate, and you get the height of the flagpole as 10 meters. So I hope this is clear. There was a little bit of thinking that goes into working out this problem, but it is not a tough question. Thank you.